you guys don't have problem in that question. Okay, so let's come to, this is our, more or less this is our last class for this quadratic equation. Okay, so let's continue. We were talking about location of roots. Location of roots of a quadratic equation. By location of roots, we have already discussed, three cases also. So by location of root, we mean, let's say you have a quadratic equation ax square plus bx plus c equal to 0. We already know it has two roots, alpha and beta, let's say, right? Now alpha and beta can be real, can be imaginary, but when we are talking about the location of the root, that means we want to locate these roots on our x-axis, right? That means our roots are already real. We don't really have to worry about whether our roots are real or not. So we will always make discriminant greater than equal to 0. Okay, we will always make discriminant greater than equal to 0. In some cases, we will also make discriminant greater than 0 only. So it will depend upon the question what it is asking. Okay, now we considered three cases. First case was, let's say both alpha and beta are positive. So I'm just going to recap quickly. If both alpha and beta are positive, and let's say if A is positive, let's say A can be positive or negative. If A is positive, then your parabola opens upwards. If A is lesser than 0, then it opens downwards. So if A is positive, that means your parabola opens upwards and the roots are positive. That means your curve must intersect the x-axis on the right hand side. That means your curve will look like something like this, or maybe something like this, right? Let's say this is your first one, this is your second one. So first one says alpha and beta both are greater than 0 and not equal. In the second case, alpha and beta are both equal and greater than 0. Both cases are acceptable because we only want to make sure that alpha beta are greater than 0. They may be equal. Okay, in this particular case, they may be equal, but they have to be positive. That's what we need to make sure, right? So what did we do? Okay, it is intersecting the y-axis on the above x-axis. So this is your f of 0, which is greater than 0, and your turning point minus b by 2a, it is occurring on the right hand side of this origin, so it must be greater than 0. And discriminant, we will take both cases. Why? Because it can be equal, it can be distinct also. So discriminant greater than equal to 0. So three conditions we learned, that is conditions for alpha beta positive is a times f of 0 is greater than 0. Second, minus b by 2a is greater than 0. And third, discriminant is greater than equal to 0. Okay, you can consider the next case also. You will again get the same condition, that is, let's say a is lesser than 0. A is lesser than 0, that means your parabola opens downwards. Your parabola opens downwards and still it must intersect the x-axis on the right hand side. So curve will look like something like this or something like this. So again, you will get these three conditions, right? Now, similarly, let's say I am saying alpha beta is greater than some particular value, not just 0. Let's say I'm saying alpha beta is greater than 2, or let's say alpha beta is greater than -5. or alpha beta is greater than -10, or alpha beta is greater than 100, then in that case, what we need is the same application of the concept, just the condition will be modified little bit. It will be almost the same, but little bit modification. So I'll cover here fourth case. Let's say alpha and beta both are greater than k. Okay, alpha beta are both greater than k. Now k can take any value, it can take any real value. Let's say -1/3, √3, √5, any value, any real value. Okay, so again we will take two cases. A is greater than 0 and second, A is lesser than 0. Okay, so remember this figure, our alpha beta both were greater than 0. Now instead of 0 we have greater than k. Okay, and the curve will look like something like this. So just let's say this is your origin. Okay, let's say this is your origin. Let's say the value of k is coming somewhere here. Okay, the value of k, the question will automatically give you the value of k. We are assuming, let's say the k is coming here. It doesn't really matter, but let's assume k is coming here. Right now, what it's saying, both the roots must be greater than k. That means our curve must intersect the x-axis on the right hand side of this k. Right, you understood this? That means, and as a is greater than 0, that means our parabola will open upwards. So our curve will look like this, or it will just touch the x-axis and turn back. Right, and instead of 0 we will use k as the reference value. Right, this 0 is of no use in this particular case because we are talking about greater than k value. Right, now again this is your x equals to k, and at x equals to k, f of k is greater than 0. We can clearly see that f of k is greater than 0, and this turning point minus b by 2a, this turning point minus b by 2a is coming on the right hand side of k, so it must be greater than k. You can say directly like this, minus b by 2a must be greater than k, and your discriminant must be greater than equal to 0. We can accept both these conditions, whether it is touching the x-axis or intersecting the x-axis, both are acceptable. So discriminant must be greater than equal to 0. Right, now let's come to when a is negative. If a is negative, then parabola opens downwards. Let's say this is your origin, and again let's say x is equals to k is this point. Now again alpha beta should come on the right hand side of this. That means your curve will look like something like this or something like this. Right, so again if I take, this is your f of k, and this is f of k is lesser than 0, and this turning point is coming on the right hand side of k, so minus b by 2a is greater than k, and of course our roots are real, so discriminant is greater than equal to 0. Right, so if we combine these case number A and case number B, then we will get the condition. We will get the condition. First condition, see, f of k is positive when A is positive. If A is positive, then f of k is positive. That means both are of same sign. If A negative, then f of k is also negative. That means both are of same sign. So we can directly say, okay, A times f of k is greater than 0. This condition includes this condition and this condition. It says A into f of k is positive. That means either both are positive or both are negative. So we are covering these two conditions in this particular first condition. Second is minus b by 2a is greater than k. Minus b by 2a is greater than k. It is same for both. So minus b by 2a is greater than k. And discriminant greater than equal to 0. Discriminant greater than equal to 0. It is common to both. So discriminant is greater than equal to 0. So whenever question comes and it says find the condition for which both the roots of a quadratic equation are greater than 5, then what do you need to do? A f of 5 is greater than 0, minus b by 2a is greater than 5, and discriminant greater than equal to 0. Is it clear? Quickly copy. Good. Very good. Quickly copy this part. Copied? Okay. Deepak, message publicly so everybody can see. Okay. So I hope everybody has copied this. Now, just remember this condition. Okay. Just remember this condition and look at the previous condition. Look at the previous condition. Case number 1, alpha beta is greater than 0. And case number 4 that we just discussed, where alpha beta are greater than k. So condition that we got is a times f of k is greater than 0. Second, minus b by 2a is greater than k. And third, discriminant is greater than equal to 0. Right? So these two conditions are extremely similar. If you just put k equal to 0 here, then you will get this condition. Okay. So should I rub this off? So I'm just going to rub this part. Okay. Now the second condition, if you remember, second case that we took was alpha beta both negative. That means both the roots of this equation are negative. So let's say again a greater than 0. Then our curve, this is your origin, okay? Our curve will intersect the x-axis on the left hand side. It will look like something like this or something like this. So this is your f of 0 is lesser than 0. Oh, I think I made a mistake. Your a is greater than 0. That means your curve will open upward. So it will be something like this or something like this. So f of 0 is greater than 0. This turning point minus b by 2a. Now this turning point is coming on the left hand side of this x-axis, left hand side of this origin. So minus b by 2a must be lesser than 0 and discriminant is greater than equal to 0. Right? If I take a lesser than 0, then again I will get the same case. It will be something like this or something like this. So f of 0 is lesser than 0. This turning point minus b by 2a is lesser than 0 and discriminant is greater than or equal to 0. So if you combine, then what condition you will get? You will get the condition. Now, f of 0 is positive when a is positive. Okay? F of 0 is negative when a is negative. That means again both are of same sign. So a times f of 0 is greater than 0. Second, minus b by 2a is lesser than 0. It is same for both. And third, discriminant is greater than or equal to 0. Okay? Discriminant is greater than or equal to 0. We have already covered this in our last class. Okay? Why I am writing this? Because I am comparing this for our next case. So we already covered case number 4. So let's say case number 5. When alpha, beta both are less than some particular value, let's say k. Okay. So we will compare with this. Let's say a is greater than 0. And because we don't really need origin, so let's say your k is somewhere here. Now, this is your upward opening parabola. So both the roots will come on the left hand side of this k. So it will be something like this or something like this. That means this f of k is greater than 0. This turning point minus b by 2a is lesser than k because it is occurring on the left hand side of x equals to k. And discriminant is obviously greater than or equal to 0. Roots are real. If we take the next case, let's say a is negative, then your parabola will open downward. It will be something like this or it will be something like this. And this is your f of k and f of k is lesser than 0. This is your turning point minus b by 2a. It is lesser than k and discriminant is greater than or equal to 0. Right? So if I want to find the condition for both the roots to be lesser than k, then I must combine these two. That means f of k is positive when a is positive, f of k is negative when a is negative. That means a and f of k are of same sign. That means a times f of k is greater than 0. Second, minus b by 2a greater than lesser than k, minus b by 2a is lesser than k. So it is same for both. So minus b by 2a is lesser than k. And third, discriminant greater than or equal to 0 for both. Right? Now compare this. Compare this alpha beta lesser than 0 and alpha beta lesser than k. The condition that we got is a times f of 0 is lesser than a times f of 0 is greater than 0. Here we are getting a times f of k is greater than 0. Minus b by 2a is lesser than 0. Minus b by 2a is lesser than k. D greater than or equal to 0. D greater than or equal to 0. So these are similar cases. So this is our final condition. Remember this. Okay, this is our final condition for alpha beta lesser than k. Is it clear? Good. I see many students are very serious here in your batch, and some of the students are not that serious. Okay, I'm seeing that they are leaving the class in between. So don't do that. Even if you find things difficult, then just ask. Okay, if you find a doubt, find any issue with respect to understanding, just ask me. I will explain it to you. If you don't ask me, then that doubt will remain with you and your performance in the test will decrease. Okay. Surendra, you have raised the hand. Do you have any doubt? Okay, good. Quickly, if you have copied, then let me know. Copied? Okay. I am covering this condition that we have already discussed in the last class so that you see that there are some similarities in the condition that we are talking about. Tell me one thing. Am I teaching fast, slow, or is it okay? Okay, very good. Now remember the third case that I taught you in the last class, that alpha, beta are of opposite sign. That means one root is positive and other root is negative. We can write it like this also. Let's say alpha is lesser than 0 and beta is greater than 0. Okay, one root is positive and other root is negative. So let's say again A is positive. That means let's say this is your origin. Your curve will intersect on the right hand side of origin once and on the left hand side of origin once. That means it will look like something like this. Okay, the curve will look like something like this. This is your alpha and this is your beta. And this is your f of 0. F of 0 is lesser than 0. Okay. Now, just look at it. If I make f of 0 is lesser than 0, if I put only one condition that f of 0 is lesser than 0, then go back to our graph theory. It is a second degree equation. Okay, it is a second degree equation, remember. And I have taken the case of leading coefficient positive. That means our curve will open upward. As x tends to infinity, it will tends to infinity. As x tends to minus infinity, it will again tends to positive infinity. So if f of 0 is lesser than 0, then remember our intermediate value theorem. It is positive here, it is negative here. So the curve will intersect at least once on the negative x-axis. Similarly, it is negative here, it is positive here. The curve will intersect at least once on the right hand side of the x-axis, on the right hand side of origin, that is positive x-axis, right? So this alone condition is enough for this case that one is positive root and one is negative root. Similarly, let's say A is lesser than 0. If A is lesser than 0, then what do I have? The curve will open downward. So it will be something like this. This is your alpha and this is your beta and this is your f of 0 greater than 0. Again, f of 0 greater than 0 is sufficient for one root to be negative and one to be positive when leading coefficient is lesser than 0, right? Because it is negative here, it is positive here, so curve will intersect at least one time. This is positive, this is negative. At least one time it will intersect the x-axis, right? Now, when A is greater than 0, f of 0 is lesser than 0. That means f of 0 and a are of opposite sign. F of 0 is positive when a is lesser than 0. Again, both f of 0 and a are of opposite sign. So we can write the condition directly. A times f of 0 is lesser than 0. Both are of opposite sign. If a is positive, then f of 0 is negative. If a is negative, then f of 0 is positive. Right? Now, let's compare it. Now, 4, 5, 6, this is our sixth case. And let's say alpha is lesser than k and beta is greater than k. That means one root is greater than k and one root is lesser than k. Here, one root is greater than 0 and other root is lesser than 0. So there is a similarity in these two cases, right? So quickly see, let's say a greater than 0. Let's say this is your k, okay? Now a positive, that means upward opening. So your curve will look like this. And at f of k, it is lesser than 0. When a positive, it is negative. Let's say a lesser than 0 case. So this is your x equals to k and the curve will open downward. So this is your case. And f of k is greater than 0 when a is lesser than 0. So the single condition is a times f of k is lesser than 0 is enough for this case. Now, for origin, we got a times f of 0 is lesser than 0. And for k, we are getting a times f of k is lesser than 0. So we have a similarity. So this condition alone is enough for this particular case. Did you understand this? Okay, good. Quickly copy. Copied. So similar cases are over. Now we are left with two more particular cases. Then this topic is over. Ax square bx c equal to 0 alpha beta roots. Now let's say case number 7. Sometimes the question is asked, what is the condition for exactly one root to lie in a particular interval, let's say in 2, 3 or 4, 5 or -7, 10. Let's say the question says, what is the condition for exactly one root of this quadratic equation is lying in this interval 2 to 3. That means your curve is intersecting the x-axis in this interval 2 to 3. If you are talking about this, then 4 to 5. Otherwise, -7 to 10. So what does it mean? Let's say this is your 2 and this is your 3. So let's say it is a upward opening parabola. I'm just taking a case. That means your curve must intersect the x-axis somewhere here. Okay. If it is -7 to 10, again the same thing, right? So we need to find the condition for that. So I'm just taking a general case. Let's say K1, K2 interval. Instead of taking a particular value, I am taking a general value, that is K1, K2. Sorry. So what is the condition for exactly one root of this equation to lie in this interval, that is K1 and K2? Let's say again your A is greater than 0. This is the interval, that is K1, and let's say this is your K2. Okay. Now it is a upward opening parabola. So it can happen that our alpha is outside the interval and beta is lying in this K1, K2 interval. That is one of the possibility. The other possibility is, let's say my alpha is lying in the interval and beta is outside this interval, right? Both possibilities are okay with us. Both possibilities are okay with us, right? Now, just see, let's say we are talking about the black curve. Then this black curve, I am just making it a dash line. Okay. At K1, f of K1 is lesser than 0. Just follow me. F of K1 is lesser than 0. And at K2, f of K2 is greater than 0. But we already know this. Again, remember your intermediate value theorem. If f of A into f of B is lesser than 0, then there exists at least one root of f of x0 in interval A comma B. Do we remember this? This is your A and this is your B. Let's say if f of A is negative, then f of B is positive. So it will intersect the x-axis here. Do we remember our intermediate value theorem that we studied in our first or second class of this quadratic equation? Do we remember this? Anybody remember intermediate value theorem, IVT? In IVT, we wrote this: f of A into f of B is lesser than 0. If they are of opposite sign, then exactly one root will lie in the interval A comma B, right? So again, same thing is happening. We are saying exactly one root lie in K1, K2. So that means f of K1 and f of K2 must be of opposite sign. F of K1 and f of K2 must be of opposite sign. Let's say if I talk about A lesser than 0, that means downward opening curve, and this is your K1 and this is your K2. So either this is the possibility or this is the possibility. This is your alpha, this is your beta, this is your alpha, this is your beta. So again, if you see, f of K1 is positive and f of K2 is negative. So again, we will arrive at this particular condition that f of K1 and f of K2 must be of opposite sign. So that is the only condition if you are talking about exactly one root is lying in the interval K1, K2. Is it clear? It is directly coming from intermediate value theorem, IVT. Clear? Good. Quickly copy. Copied? Okay. This is just the application of the concept that we have already studied. We have done the 7 case. Let's come to case number 8. Let's say it says that both the roots lie in K1, K2. Before we did that, exactly one root lie in the interval K1, K2. Now we are talking about, let's say, I want both the roots of my quadratic equation to lie in this interval. So again, quickly consider, let's say, leading coefficient positive, and this is your K1 and this is your K2. That means your curve will intersect the x-axis 2 times in between K1 and K2, or it will just touch x-axis and turn back, right? Alpha beta lying in K1, K2 means alpha can be equals to beta or it can be different from beta, right? So we need to consider both cases. So again, see, f of K1 is greater than 0 and f of K2 is again greater than 0. This turning point minus b by 2a, it is coming in this interval, so it must be lesser than K2 but greater than K1, and discriminant must be greater than equal to 0. The roots are real, so discriminant must be greater than equal to 0, right? Let's say your leading coefficient is negative. This is your K1, this is your K2. So it should look like something like this, or just touch the x-axis and turn back. That means f of K1 is lesser than 0 and f of K2 is also lesser than 0. And this turning point minus b by 2a, it is lesser than K2 but greater than K1, and discriminant is greater than equal to 0. Okay. So let's combine these two conditions. First, discriminant greater than equal to 0, common for all. Second, minus b by 2a lying in the interval K1, K2. So minus b by 2a is greater than K1 and lesser than K2. And the third condition, see, f of K1 is positive when a is positive. F of K1 is negative when a is negative. That means a and f of K1 both are of same sign. So a times f of K1 is greater than 0. Okay. Again, f of K2 is positive and a is positive. F of K2 is negative and a is also negative. So a into f of K2 is also greater than 0. So these are the 3 conditions for both the roots of this quadratic equation to lie in interval K1, K2. Quickly copy. Copied? Okay. So the last case then with this, and we are over with this quadratic equation chapter. Satvika says tomorrow for class holiday. Why is it holiday? Why tomorrow is holiday? Is there any festival there? Ganesh Chaturthi. Okay, okay. Thank you, and same to you guys too. Happy Ganesh Chaturthi to all of you. Vijay Chaturthi, yes, okay. That's why I'm asking. Okay. If it is a holiday, then you will be conveyed so. Okay. You will get a call from our college that tomorrow is holiday. If it is holiday from our college. Okay, thank you. Now let's come to this ninth case. In the eighth case, we said alpha beta, let's say this is your K1, K2. Let's say this is your K1 and K2. Okay. K1, K2 is the interval. In the eighth case that we just studied, we said, okay, alpha, beta both lie in this interval. Alpha is also lying in this interval and beta is also lying in this interval. That means K1, K2 and alpha and beta both are lying in this interval. Now, in the ninth case, we are reversing the situation. We are saying, okay, this is your alpha and this is your beta. I am saying now, what is the condition if K1, K2 interval lies between the roots of this equation? First, differentiate between case number 8 and case number 9. Case number 8 says our roots lies in the interval K1, K2. In the case number 9, we are saying the interval lies in between the roots. Okay. So the case number 9 is, I will draw it a bit below so that I can write the name also. First, K1, K2 lies in between the roots of equation. So let's say A is greater than 0. So let's say this is your case, this is your alpha and this is your beta. Then K1, K2 must lie between these two roots. Okay, I hope the difference is clear between case 8 and case 9. In case 8, we are saying roots lie in the interval. In case 9, we are saying the interval lies between the roots. So if you see, f of K1 is lesser than 0. Okay. Now just focus. It will take only 2 minutes. So focus. Let's say I am making f of K1 negative. Okay. So this is the negative value. And because I have already taken leading coefficient positive, so it must be somewhere positive here, right? So positive to negative, it means the graph will intersect the x-axis before K1. So this is what we are getting, right? Similarly, this K2, this is your f of K2 is lesser than 0. Okay, so this is your negative value, and A is positive, so it will be positive somewhere here. So negative to positive, the graph will intersect at least one on the right side of K2. So our work is done, that one root is lying before the K1 and other root is lying after the K2. That means K1 and K2 is lying between the roots alpha and beta, right? So let's say second case, A is lesser than 0. So this is your K1. Let's say this is your curve. This is your alpha and this is your beta and this is your K1 and this is your K2. So f of K1 is greater than 0. F of K2 is also greater than 0. Now A is negative, so it will be negative here. F of K1 is positive, that means the graph will intersect the x-axis before K1. So one root is lying before K1. F of K2 is positive and here it is negative. That means it will cut after the K2. So one root is lying before K1 and other root is lying after K2. That means K1, K2 lies between these two roots, right? So condition let's look at the K1 first. F of K1 is negative when A is positive. F of K1 is positive when A is negative. That means both are of opposite sign. A times F of K1 is lesser than 0. Second, same for F of K2 also. F of K2 is negative when A positive. F of K2 is positive when A is negative. So A times F of K2 is negative. These two conditions are enough for roots, for the interval to lie between the roots. Quickly copy. I wanted to solve one question from my side, but it's okay. I'll give you the homework and we will discuss it in the detail. Okay. Quickly copy. Copied? Okay. Everybody must attempt this question. This question will cover all the cases that we have talked about. And remember, this location of roots topic, it is very, very important. Okay. Pick previous year's question. You will see many questions are asked from this particular topic. Okay. In JEE main also and advanced also. Okay. So remember the conditions, practice, you will remember the conditions. Let x square minus a minus 3x plus a equal to 0, where a is real. Okay, a is real. Find a for which roots are real and distinct. Second, opposite in sign. Third, both roots positive. Fourth, both roots negative. Fifth, one root smaller than 2. Other is greater than 2. Sixth, both roots greater than 2. Seventh, both roots smaller than 2. Eighth, exactly one root in 1, 2. Ninth, both roots in 1, 2. 10th, one root greater than 2, other root lesser than 1. Okay? So you need to find the value of A for each part. Okay? And all of you must attempt this question and submit in our Telegram group. I will not take class tomorrow. I will take after that. Okay? So you have 2 days. Either you submit today or you submit tomorrow night, by tomorrow night. Okay? So all of you must attempt these questions, and whatever your answers are, whether you are getting right answers, wrong answer doesn't matter. Your process matters. Okay? So always share your answers. Do not worry about whether your answers are right or wrong. Okay? You are allowed to make mistakes before the exam, before your real JEE main and advanced exam. Okay, guys? See you in the next class. Okay. Thank you, guys.